Wow, what a warm welcome. Thank you so much, Pensacola. So I want to thank Dr. Ford for the cordial invitation down here. Also want to thank Roger and Orth and their courtesy for providing me with the house. Very much appreciated. So let's just go ahead and get into it. This talk is based on a scientific paper our research group published in the American Journal of Clinical Nutrition in 2005. And to say the least, I've gotten incredible mileage out of this paper. It's taken me all over the world. So as a matter of fact, I'm going to be in, where am I going to be? I'm going to be in Rome in 2 weeks giving a similar talk. So a lot of mileage on this. All right, so anytime we're talking about the origins and evolution of the human diet, what we're really talking about is the origins and evolution of humanity itself. And so let me walk you through this slide because this is going to set the stage for the rest of the lecture. And if you look carefully up here, there's a couple of key items that we need to consider. The first thing is the word hominin. And what hominin means is a bipedal ape. And so what all of these little boxes here, these rectangular boxes represent are hominins. So these are different species of our ancestral humans. And the length of the box indicates the time in the geologic record in which we find these fossils. And so these ones that are labeled in green right here, we're not sure if these are apes or if these are hominins. So these are kind of the last common ancestors. And you notice then that the period at which we became hominins and bipedal happened roughly 5 to 7 million years ago. And as we move in this direction, you can see these pink boxes represent our own genus Homo. And so as we move further on up, you can see that here's Homo sapiens. And Homo sapiens, our own genus and species, has only been around for about 200,000 years. And there are no other hominins that are left. We are the remaining ones. There's two key periods that we need to consider for this lecture, and one is the Pliocene. The Pliocene goes back to 5 million years ago, and then we need to look at the Pleistocene. The Pleistocene happened about 1.7 million years ago on up to the present. And this is when really all the action happened, when we became human. And so we believe that diet was one of the environmental factors, perhaps the most important environmental factor that allowed us to become human. And we're going to get into this issue with the lecture. So there may be as many as 20 hominin species that existed. They simply did not have one diet. We talk about the paleo diet or the Paleolithic diet, the old Stone Age diet. There really wasn't one diet, and that diet varied by geographical locale, season, and other factors. So let's talk about that period, the Plio-Pleistocene, and what do we know about that period for sure. So we know that our ancestors ate an omnivorous diet. They ate both plant and animal food. The difference between their plant and animal foods compared to ours is that they were wild and unprocessed. They simply did not have the technology to process their foods. And so these are some really cool photographs taken by Richard Lee at Harvard. And these photographs were taken of the Kung people in the 1960s and late 1960s. And so if you look carefully up here, I know the people up front can probably see this, but this fellow actually has a stone tool in his hand, and this was an experiment to see if you could butcher African animal with these stone tools. And it turned out they were very effective tools at butchering and disarticulating the carcass. If you look up here, now these guys are sitting around doing nothing, and of course the women have gone out and gotten all the food. So, yeah, we've changed so much, haven't we? So you can see right here, if you take a look carefully, I know in the back it's going to be a little bit more difficult if you could dim the lights, but I guess we can't. But you'll be able to see that, look at the size of her fist right here, and then look at the size of this thing that looks like a watermelon. It's a tiny little watermelon, and indeed, that's where watermelons came from. They're indigenous to Africa. So she's gone out and collected these melons. These are called tama melons. And if you notice over here, here's some berries, and here's some roots right here. And see this stick? That's how she dug up these roots, is with her little digging stick. And right here in the middle, I guess you can see it, I've given it away, but that's a tortoise. So when women go out and gather, they get both plant and animal foods. So what can we say about the the Pleistocene diet, and how do we know that it was omnivorous? What is the evidence to support that notion? If we look at our closest living ancestors, that last common ancestor about 5 to 7 million years ago probably didn't look a lot like a chimpanzee, and it didn't look like us. It looks like something in between, because chimps have evolved as well. But chimps are primarily frugivorous. They eat a lot of fruit in their native environment, but they also eat a lot of meat during the dry season. And if you look carefully right here, this is a male chimp, and they go out in the forest in packs, probably 4 to 7 males or even more, and they chase around these little colobus monkeys, and they also chase around small antelope. And they catch them with their hands, but they don't have large carnivorous carnassial type teeth to be able to tear apart the flesh. And so how they kill them is they body slam them. They grab them and then boom, they pound them to the ground. And then it takes them forever and a day to disarticulate the carcass with their small teeth. And they literally eat everything. They eat the brains, they break open the bones and eat the marrow, and they eat the meat and so forth. So they eat close to a quarter pound of meat a day during the dry season. So that is indicative that perhaps all hominins were meat eaters. This is even more powerful data. This is a stable isotope data. And if you look carefully up at this fossil, this is one of the more famous fossils. This is called the town baby. And you see that if you look at the teeth right here, the enamel is still intact on the teeth. And because of that, it allows us to go into this tooth and measure an isotope called delta 13 carbon. And by analyzing this isotope, we can determine what this particular creature has been consuming. And so if there's more of these C3 type foods, this is a browser. This is an animal that consumes the leaves, shrubs, and herbs. And if there's more of the C4 isotope, it's consuming more grass, because grass has a different photosynthetic pathway than do herbs. And so the signature that ends up in the carbon of the tooth is different. And so if we look at these blue squares right here, these are members of Homo, our own genus, and these are hominids that came before Homo. And notice that their signature falls halfway between browsers and grazers, and it's quite similar to obligate carnivores like hyenas and lions and these animals that are now extinct. So animals that eat these other animals, if you're a lion or a hyena, you're going to eat both a browser and a grazer, and that's why they have a mixed signature. And so the interpretation here is that these guys were also eating both plant and animal foods. So this is the uncertain part of the diet, is how much plant and how much animal food were being consumed. And let's go back to that original diagram. And what we can say is, starting in about 2.5 million years ago, and it's somewhat coincident with the evolution of our own genus Homo, where there's evidence to show us that we're starting to eat more and more meat. And I'll show you that's probably one of the key environmental factors that allowed for a large metabolically active brain to evolve. So what is that evidence? If we look in the fossil record, stones don't leave us, okay? They're basically here almost forever. And these are stone tools that were unearthed in Ethiopia, and this is the guy that actually found them. And if you look carefully up here, you'll see there's two types of stone tools. There are these sharp flakes, and the sharp flakes is what these guys are really after when they're making the stone tools. They can be used to disarticulate a carcass, and modern day experiments show that they're very effective at cutting open skin and getting muscle and bone away from the carcass. The second part is this core, which it was the resultant part from this chipping process, and this is effective at smashing open skulls and getting at brain tissue. It's also effective if you put it on an anvil stone and getting at marrow. So we think that marrow and brains were some of the key dietary factors that allowed us to become human. All right, this is one of the most cool fossils ever found, and this is the jawbone of either a hartebeest or a wildebeest. And if you look up here, there's a little scratch mark, and if we magnify it with scanning electron microscopy, there's a very characteristic mark that is not a gnaw mark from another carnivore, nor is it a stone mark that happened to randomly scratch this while it was being fossilized. So we know that this is indeed a cut mark, and it's on the medial side of the jawbone, meaning the inside. So what do you think they were after? Yeah, they were after the tongue. And so work from our laboratory shows that the tongue actually is a high source of monounsaturated fats, which are healthy fats. And the same thing is true with marrow, is when they cracked open the marrow, they were also extracting a food that was also very high in monounsaturated fats. So these are very healthy fats in terms of what they do for cardiovascular disease. Okay, here's another very intriguing bit of evidence. This was the so-called expensive tissue hypothesis, and this was invented by my colleague Leslie Aiello at the University College in London. And this paper came out in 1995. And if we look at our brain size and we contrast it to our gut size, we have incredibly large brain and we have a very small gut. If we were to look at all other primates, monkeys and apes and so forth, and we were to predict what a 65-pound or 65 kilo primate ought to look like, we should have a very large gut and we should have a small brain, but we don't. And so the implications of this, there was an evolutionary trade-off to evolve a large brain at the expense of having a reduction in our gut size. And so this is how we interpret this, is if you look at this slide and you envision a brain is the hottest organ we have, quote unquote. Metabolically, it uses more ATP than any other organ in the body. About 9 times, as you're at rest right now, 9 times the amount of energy is devoted to running that brain. So think about it. If we had a brain that was filled our entire body, my God, our metabolism would be out the roof, wouldn't it? And so this is the key to understanding this expensive tissue hypothesis, is that we actually measured our overall metabolic rate, and guess what? It turned out to be the same as all other primates. So inferred on that was the notion that another organ's metabolic rate had to decline, and indeed that's what happened. So we started to have this, we had selection for a smaller gut, which allowed for the selection of a larger brain. Well, how did that happen? Remember what the diet of the chimpanzee was? Primarily fruit, and so and plant-based food. So as we started eating more and more meat in our diet, which is more calorically dense, then that was the selective pressure that allowed us to evolve a larger brain. So here's some really interesting data. If we look at where all hominids actually originated, they originated in this East African area here, all the way down to South Africa on up to Kenya. And the origin of Homo, our own genus, occurred about 2 million years ago. So this is a very cool fossil that was found 1.65 million years ago. But notice that the first fossil hominid found in Europe was found in this site called the Dmanisi site in Georgia, present-day Georgia, and it's dated to 1.8 million years ago. So what that tells us is that our own genus somehow had to have gone further north. And so the idea is that we either walked down the Nile and we crossed right up here, and then we went up through this Black Sea area. The Black Sea actually didn't exist then. And this is how we got to 40 degrees north latitude. Now, I don't know about you folks here in Pensacola, but I live in Colorado, and we're at 40 degrees north latitude right now, and the ground is still frozen. There's no food. So if you're foraging, you've got to have animal food as a major source of your diet. So the behavioral adaptation to either to hunt or to scrounge animal food had to have happened at lower latitudes before we could have got here. So even during the interglacial periods, you had to have animal foods to live at these very far north latitudes. Okay, this is some interesting data, and this is stuff from our laboratory. If we look at cats, cats are obligate carnivores, meaning that they have to get all of the nutrients that they need for their bodies from their total animal food-based diet. And so I don't want to get into too much of the biochemistry, but if we look over here at vitamin A and beta-carotene, just a basic metabolic change that we can do in our liver, if we eat carrots, which have a good source of beta-carotene, we can turn them into vitamin A. But we don't do that process very well at all, okay? And vitamin A is absolutely essential for every cell in the body. Cats can't do it at all. So if you were Linda McCartney and you're trying to make your cat a vegan vegetarian, you'll kill it, all right? So where do you suppose these guys, before we were feeding them cat food, if they can't convert beta carotene, where do they get vitamin A in an animal food? The organs, yes. So liver is a good source of vitamin A. Marrow also has vitamin A in it, and believe it or not, tongue has vitamin A in it. And so these other biochemical pathways, if we have any biochemists in the audience, this is the same type of a situation. So let's go back to the uncertain. How much plant food and how much animal food were being consumed in their diet? We know that they were eating more and more animal food, but what is the percentage? Because this is the evolutionary template that we need to address when we talk about a healthful diet in this modern age. Should we be eating a vegan, vegetarian diet? Should we be eating a high meat diet? What is the evolutionary template? Because it provides us insight into how we should be operating now. So this is a paper we published all the way back in the American Journal of Clinical Nutrition in the year 2000. And what I did here is I compiled data from a document called the Ethnographic Atlas. And the Ethnographic Atlas went out and it looked at all of the world's hunter-gatherers. And so in the early days, there were frontier physicians, there were anthropologists, there were explorers that went out when there were still hunter-gatherers on the planet, and they made notes about what these people were eating and plant and animal food and so forth. And admittedly, this is pretty soft data, but it's some of the only data that still exists. So we went through and compiled it, and we published our results. And let me show you what we found with this soft data, and then I'll show you some better data. So let me walk you through this little frequency histogram right here. And we examined the amount of gathered plant foods in 229 hunter-gatherer societies. And so we broke it into 1 of 10, we didn't, this was data that was already pre-existing in the Ethnographic Atlas. It was broken into 1 of 10 categories, 0 to 5% plant foods, all the way up to 86 to 100%. And notice the value here in the middle, this represents the mode, which is the most frequently occurring value. 45 societies consumed 26 to 35% of their calories as plant foods. It's also the median, the value that falls halfway between one and the other value. The other point I want to make out is, look, there is not a single vegan, vegetarian society in this whole mess. And the reason why there isn't is because this diet is lethal unless you supplement with vitamin B12. And they didn't have supplements back then. So, and notice here also that only 13.5% of the societies have more than half of their foods from plant foods. So at least this evidence is somewhat supportive of the notion that whenever and wherever possible, we would try to consume animal foods. And so this graph represents the total fished and hunted animal foods in the diet. And you'll notice then that the mode and the median right here fall at about 56 to 65. So a little over half to 2/3 of their calories came from animal foods if and when it was possible. All right, take a look at those 6-pack abs on those guys. So I've seen many photographs of hunter-gatherers, and this is a fairly typical photograph. This is how they looked. And the problem with the ethnographic data is it's very subjective. What if it was a man who went out in the field and he was looking at the food that was being brought back in? Maybe that man ignored what the contribution of the female and the children and the grandparents was from the collected foods, and he paid more attention to that. So it's very loose data. And what we ended up doing in another paper is we went in and we found the 13 studies that were quantitative. And these are studies in which they were actually able to measure the foods that were consumed, the total weight, the calories, and so forth. And there were 13 of them. And we ended up eliminating 2 of them. We eliminated the Eskimos right here. And notice they are living in Greenland at 69 degrees north latitude. And they were eating 96% animal, 4% plant. Well, that skewed our results because they didn't have a choice, except for a month or two out of the year. They couldn't do it. And the same thing here with the Nunavut people. Once again, 99 and 1. So if we take those two values out, what we see is a similar value. About 2/3 of the energy come from animal foods and about 1/3 from plant. So this corroborates the data that we had from a previous study. This is my colleague Mike Richards at Oxford, and this is one of the most cool fossils found of all time because this fossil we've actually sequenced the Neanderthal genome from. So there's actually a series of fossils, but this is one of them. This is a mandible dated to 29,000 years from a cave in Yugoslavia called Vingia. And we're looking at another isotope here, and the isotope we're analyzing is delta 15 nitrogen. And what this isotope does is it tells us how much animal food those Neanderthals were eating. And so what we have to do is we contrast that isotope to other animals, to other fossils found alongside that Neanderthal bone. And you can see there's a wolf, an Arctic fox, and bison and deer and so forth. And carefully look at the signature here. This is the Neanderthal. It has a signature that is virtually identical or higher than a wolf or an Arctic fox. So Mike's point is that the Neanderthals were clearly behaving as top-level carnivores. Now, Neanderthals aren't us. That's a different, there's the same genus but another species. So let's take a look at Mike's data from some more modern people. These are fossils that were found in England in a place called Gough's Cave, and there were 5 Homo sapiens dated to about 12,000 years ago. And what you can see is, once again, 12,000 years ago, they had this signature that was almost identical to this Arctic fox, which is not an obligate carnivore, but gets most of its calories from animal food. So this data also supports the notion that humans, whenever and wherever possible, are eating a lot of meat. Okay, so you don't have to be a scientist here on this one. This is pretty intuitive. So we know they were eating minimally processed wild plant and animal foods, and that should be the template that we use for our modern diet. And so obviously they simply did not have the technology to produce these types of foods, okay? So what's wrong with eating this food versus eating this food? Yeah, you may not think about it, but once again, sometimes pointing out the obvious is one of the most difficult things to do. You know, the king is not wearing clothes. So this is what we did in a paper published in the American Journal of Clinical Nutrition in 2001. And we went in and looked at the disposal data in the United States, and it turns out that 70% of our calories come from basically 4 or 5 different foods: breads, dairy, refined vegetable oils, and sugar. Okay, if you take cereal and combine it with vegetable oil and sugar, you can call it a cookie, you can call it a donut, you can call it a cracker, you can call it whatever you want, but it's the same combination of all these same ingredients. So these things comprise 70% of the calories in the typical Western diet. We eat the same things day in and day out. And another way of looking at it is with this pie chart. And I've deliberately put this pie chart together to show you the foods in white these are the recent foods. These foods have all been put into our diet since the industrial era and the Neolithic period. And we'll talk about what that is here just shortly. And so these foods are calorically less dense. They have less vitamins, less minerals, less phytochemicals, and they have weird fatty acid profiles. And so by default, if you look up here on that pie, if you put those in, what do they do to the rest of the foods, the real foods, the meats, the fish, the fruits and vegetables? They compress it. And so our diet becomes nutritionally less dense. The vitamins and minerals are less when you include these in your diet. So they displace those foods, and it has important health implications. This is the period called the Neolithic, and this is the period when we changed as a species from living as hunter-gatherers to becoming farmers. And it's a period that occurred from about 10,000 years ago, when the agricultural revolution first began, to about 5,500 years ago. And so we first domesticated animals 10,000 years ago. 10,000 years ago, my God, that seems so long ago. It's so historically remote, but on an evolutionary time scale, a generation is considered to be 30 years. That's only been 333 human generations. So we still have the genetic makeup of Stone Agers. We are literally Stone Agers living in the space age, and we have genes and bodies and digestive systems that are very well adapted to the foods that we have always consumed. And so these recent introductions, here's the first time cereal grains were introduced. Believe it or not, we talk about grains as the staples and the staff of life. They have only been domesticated in the same time frame. The first dairying evidence we see from about 9,000 years ago, but probably people were consuming dairy products once they had domesticated these animals. So this just represents a lag in the fossil record. Okay, wine and beer. Nobody had any fun until 6,000, 7,000 years ago. Okay, the first salt mines in Europe appear about a little bit after that. And sucrose, which is table sugar, was first produced in India about 2,500 years ago. But the thing is, it was made from cane sugar, and it wasn't exported around the world. So only a few people had it, and the rest of the world simply didn't have it until much later. Okay, the Industrial Revolution, this is when things really started to change, and let's take a look at this. Okay, so this is when table sugar, or sucrose, became available to the masses, was starting at about 1798, the turn of the century, whenever, 200 years ago. Okay, feedlot produced meats, fatty meats. That never ever happened. We didn't have the technology to bring cows and grain to market and produce these fatty meats that are ubiquitous in our diet now. Refined grains, okay, white bread, white rice, all of these things are technological innovations. We never did these until fairly recent times, and I'll show you the technology that allowed for that. Refined vegetable oils. In all processed foods, we put refined vegetable oils in them, but once again, you can see a very recent addition to the Western diet. And when you look at it from a generational perspective, obviously our genes have not changed in 3 or 4 generations. We have the same genes, our grandparents, our great-grandparents. We have basically the same genes that people had 10,000 years ago. So this is an onslaught to our physiology and our health to throw 70% of our calories into our diet in the mere time frame of 4 or 5 human generations. Hydrogenated vegetable oils a little bit later still. And HFCS, what's that? High fructose corn syrup. Now, when I was as young as some of the people here in this audience, this stuff didn't exist, all right? Okay, this is kind of a fun slide. We'll just rip through it, but this is when processed and junk food came about. There's Hershey chocolate bar, 1900. We can hear applause if we hit one of your favorites. Pepsi, 1902. Kellogg's Corn Flakes, 1906. Crisco, 11. Oreos have been around since 1913. I guarantee you they'll never, ever go away. Wonder Bread, 1921. Rice Krispies, those Rice Krispie treats? You couldn't have eaten those before 1928. Oh, Corn Chips, 1932. M&Ms, now that's one that definitely will not go away. Sugar Frosted Flakes, and Pringles Chips, 1969. Okay, so when we look at these Neolithic and industrial era food introductions, they cause a lot of problems in our physiology and our health and our well-being. We identified 7 key characteristics, and let me just walk you through these because you may not have a nutritional background, but the glycemic load is very important. The way a food impacts our blood sugar, we can measure it. And foods that really raise our blood sugar or blood glucose have high glycemic loads. So the white bread right here, these potatoes, and this drink all absolutely do a number on our blood glucose. The unfortunate part of this is they also elevate our insulin. Insulin is a master hormone, and it causes lots and lots of problems. Fatty acid balance. The types of fats that are in this hot dog are way different than what we find in the tissue of wild animals. The macronutrient balance. In the Western diet, we eat primarily carbohydrates. They're our major source of energy, whereas in Stone Age diets, the predominant energy source was either protein and fat, and carbohydrate was always low. And so that's a characteristic pattern, high protein, low carbohydrate, that we're finding out now from randomized controlled trials is healthful for humans. Trace nutrient density. There's no vitamins and minerals in here, and when you consume that, you are displacing real food, fruits and vegetables. Acid-base balance. We'll talk about that in a little bit, but if you eat a lot of fruits and veggies, you have a net base-yielding urine. And sodium, potassium, we salt everything, so we have way more salt than we do potassium, and there's no fiber left in these things because they're entirely fiber depleted. These 7 nutritional characteristics wreak havoc with our body, and we can trace them to many, many diseases. The symphony orchestra plays not with a single instrument, but together. And so all of these factors synergistically impair our health and our well-being. Okay, let's look at these one by one and show you why they were not part of the hunter-gatherer diets. Let's take a look at cereal grains. If we look at grains, about 1/4 of our calories come from cereal grains. Unfortunately, this is the type of cereal grains we eat in America. We eat these refined grains with high glycemic load, and that adversely affects our health and well-being. How do we know that hunter-gatherers didn't eat cereal grains? Well, first off, cereal grains are the seeds of grasses. And in their wild state, they're very small, they're difficult to harvest, and you got to do a lot of things to them to make them edible. You got to grind them up and you got to cook them. Otherwise, the starch and the proteinism is not available to you. So it represents a lot of work. And there's a theory called optimal foraging theory in anthropology. And if you go out and you're a forager, you got to get more energy from the food than you expend. Okay? If you go out and you hunt and gather all day long, you come back with 50 calories, it's a bust. So you got to come back. You got to get more energy than what you expend. And these foods are rotten at getting energy back because it takes so much energy to collect them and process them and cook them and build a fire and all this that hunter-gatherers basically ignored these and viewed them as starvation foods. So when do we first see these grains being included in our diet? It's when in the fossil record we see these crude grinding stones. And so this occurred in a culture in the Mideast called the Natufians, roughly 10 to 15,000 years ago. Up until about 1880, the way we ground our cereal grains up to make our bread and our flour was with these stone grinding tools. This is how it was first done. And then later on, we built these water wheels that turned these gears that ground these stones together. And when we made our flour, everything was mixed together. There's 3 parts of a wheat berry. There's the germ, the bran, and the endosperm. And so when we do it like this, everything gets mixed up together, and we call that flour 100% extraction flour. So that's perhaps not as unhealthy as white flour. And that's pretty much how it was done up until about 1880. And then in 1880, what happened, we invented these things called steel roller mills. And if you look up here, you can see that we fundamentally have changed the way in which we're breaking up the wheat berry. Instead of pulverizing it and grinding it with these stones, we're putting it through and squeezing it. And when we squeeze it, a couple of things happens is the germ and the bran come off as a nice little flake, and we can sieve them out very easily. And then once we sieve them out, we don't stop there. We continue putting the flour through multiple breaks until we get these tiny little particles, and that's what we make our white bread out of. Now, it was done at the time because people liked this nice white flour without any bran or germ in it, but had they known the adverse health effects of doing this, it probably would have never happened. So here's what happens to the glycemic index. We talked about the glycemic index, the ability of a food to raise our blood sugar. And what you see right here is we start off with a whole wheat kernel, 100% extraction, where we keep the bran and the germ and everything intact. It has a low glycemic index. And by the time we're down here to making these fancy flours that we use for all kinds of fancy pastries and whatever, the glycemic index has risen to 70 or 80. And if you look over here, this is a list of foods. These are common cereal, refined grains. And you notice almost every single refined grain up here has a high glycemic index, which is defined as greater than 70. So you think about healthy foods like Cheerios, they're advertising them as heart healthy. Well, I don't think so, not based on the glycemic index by any means. And so what's some other ones here? People like bagels. You can see bagels are typically high glycemic load foods. All right, well, what's wrong with high glycemic load carbohydrate is that if you eat these things over the course of your lifetime, they tend to promote a condition called the metabolic syndrome, which is when our body becomes resistant to insulin. And when the body becomes resistant to insulin, what happens is the pancreas secretes more of it. So the muscles say, hey, I'm full, I don't need any more food, I'm done, don't give me any more insulin. So what the body does is it sacrifices the insulin for the blood glucose. To keep blood glucose low, it secretes more and more and more insulin. And so we have this chronic state of high insulin, and that's associated with all of these diseases that you see here, type 2 diabetes, hypertension, heart disease. You go down to your cardiologist or your physician and you get your blood chemistry measured. I'm sure most of you have had that done. And this is what they're measuring. These are the values that they measure. And what we see with the metabolic syndrome is a very characteristic reduction of HDL, which is the good cholesterol. We have blood triglycerides elevated, and we have LDL, which is increased. Okay, something that even if you're involved in nutrition, you may have never heard of is the concept of acid-base balance. And if we look at all foods, they report ultimately to the kidney as either acid or base. And so you can see all grains are net acid yielding. All the ones in red are acid yielding foods. And notice that cheeses, paradoxically, are almost an order of magnitude higher in their acid yielding than any other food. So we'll show you that the problem is net acid yielding foods tend to promote osteoporosis. The only base yielding foods are fruits and veggies, and we don't eat very much of these in our diet. And so consequently, the Western diet is net acid yielding, and this is how it works out. You can see that grains provide a quarter of the energy, they're acid yielding. Meats are acid yielding. Cheeses, except for milk, which is about neutral, are acid yielding. And salt, of all things, yields acid ions to our kidney. And we eat very little fruits and vegetables. Less than 10% of our calories in the US diet comes from fruits and veggies. It's almost guaranteed that if you do this over a lifetime, both men and women will become osteoporotic. So what are the diseases associated with a diet that is net acid yielding? Osteoporosis, high blood pressure, kidney stones, and stroke. So this is how we eat. We consume these foods, and if you look up here, you have trouble seeing any fruits and vegetables. There's some parsley, and I don't know, maybe a slice of tomato over there. Okay, what happens to refined grains? What happens to the vitamin content after we refine grains? Well, you can see this right here. Whole wheat, you could see, has much greater concentrations of almost all of these vitamins, and you can see what happens here to all these other vitamins. We started to enrich our flour after World War II with these 3 B vitamins and iron, and I'll show you that here in a minute. And then since 1998, we've put folic acid, not folate, back into our diet, and it's turning out that's probably not a very good idea. It's increasing our risk for prostate cancer. It reduces the risk of neural tube defects in infants, but it's a kind of a Pyrrhic victory. It's a trade-off that doesn't seem to work very well. Okay, well, let me go back one other point. So when you take out all the vitamin B6 and you take out all the folate, this increases a chemical in our bloods called homocysteine, which irritates the lining of our arteries and promotes cardiovascular disease. This is what happens to the mineral concentration of flour, and you can see all the minerals get knocked out completely, and there's a whole bunch of diseases associated with it. The calcium that's available in whole grains, it's bound to a compound called phytic acid or phytate, so we actually don't get any of this calcium anyway. And these are some of the diseases associated with poor calcium intake. Now, if you decide to do the paleo diet and you go to your physician or your nutritionist and you say, look, I'm going to cut grains, whole grains out of my diet, they're going to go, oh my God, where are you going to get your fiber? You're going to have no fiber, you're going to be constipated for the rest of your life. That's not true. If we look at whole grains and we contrast the fiber content to a 1,000 kilocalorie sample, notice that we have almost twice as much fiber in fruits and non-starchy vegetables. Is completely off the roof here. So this is a myth, and fiber has important effects on our health, particularly the types of fiber that are in fruits and non-starchy vegetables. There's soluble fiber versus the insoluble fiber in whole grains, except for oats, which has a little bit of soluble fiber. And so there's the laundry list of diseases for the gastroenterologists in the crowd. And some of these aren't completely bought into, so some of these have changed a little bit. How do we know our ancestral diet we didn't have dairy products? Okay, so take a look up here, look at this. You know, anybody ever try to walk up to a wild animal? How about doing this to it, you know? It's just not going to happen. See, you have to domesticate an animal before you can milk it. And so people simply couldn't have had dairy products in their diet until we domesticated animals. This is how the numbers come in for dairy products. You can see we eat about 10% of our calories as dairy, and this is how it mixes up. And so you've already seen this slide. This is when we first find evidence of dairying about 9,000 years ago. What's the problem with dairy products? They have a really weird fatty acid balance. All foods, fatty foods or animal foods, are a mixture of polyunsaturates, monounsaturates, and saturated. But you can see here, if we look at wild animal tissue, we have a pretty good mix between monounsaturates and polyunsaturates, and we have a lesser amount of saturated here. But we have a very, very good mix. Whereas with dairy products, you can see we have low levels of polyunsaturates and very, very high level. And so if you include a lot of fatty dairy foods, it tends to imbalance fatty acid and tends to promote some diseases. Now, I kind of reversed my position a little bit on the saturated fat thing, and I think most of the world has started to see a little bit different perspective. So in terms of increasing the risk for heart disease, it does, but it depends on what you replace saturated fats with. If you replace saturated fats with carbohydrate, you're in worse shape than starting off with saturated fats. That's what the most recent information shows. So what we ought to be doing is replacing saturated fats with what we had in our diet originally, monounsaturates and polyunsaturates. This is a very healthy profile. Okay, so if you look at dairy products, and we talked about the glycemic index and how that promotes many, many diseases, you'll notice that refined grains have really high glycemic indices. But come down here and look at milk and yogurt. My God, look at how low they are, 27 and 24. At least in theory, they ought to be healthy foods. But work from our laboratory right here, this is one of my graduate students, Gerard Hoyt, turned out differently. And what we found is that they knock our insulin levels sky high. It's just like eating cookies, okay? So let's take a look at that data. And you can see here that all dairy products have very, very low glycemic index. That means they don't jack our blood sugar levels up. But paradoxically, look at, compared to white bread, yogurt has an insulin index that's even higher. So all of these dairy products have these enormously high insulin index. And there is at least one experiment in children showing that it produces insulin resistance. A high dairy product or a high dairy diet for only 1 week caused insulin resistance in children. That experiment hasn't been repeated yet in adults, and that's what we want to do in our laboratory. Okay, so another thing is they really didn't eat fatty meats, all right? They ate everything. They ate the entire carcass, but wild animals don't have a whole lot of fat on them. And let's take a look at that data. So here's the staples in the American diet. This isn't meat, this is fat disguised as meat, okay? And when you look at the percentage of fat and protein, what we really need to look at it is not a percent by weight, but percent by energy. Because at the end of the day, we eat calories, we don't eat weight. And so when we look at these values by energy, you can really see that these types, look at hot dogs, my God, it's 82% fat, 14% protein. So these are very, very unnatural compared, and I'll show you some really good photos. If you look at body fat in wild animals, it waxes and wanes seasonally. And so once we invented agriculture, what we could do is we could feed fodder to our animals, and we could prevent this seasonal loss in body fat, and we weren't stupid enough to slaughter them when they were all leaned out. We slaughtered our animals when they were the fattest. So that changed things considerably. Whereas when we were hunter-gatherers, we were at the mercy of the seasons. We got whatever fat the animals had on them. And so this slide just shows you how the body fat, this is body fat percentage on the y-axis here, you can see how it changes month by month. And in North America, the fat in North American animals peaks just after summer, and then it falls again as we move into winter. And if we look at that data and we combine it all, I point this out to you, is that the average body fat in these wild animals over 7 months is about 3%. From January until July, it's about 3%. And then it goes up. But over the course of the entire year, the average body fat's only about 7%. I bring this data up because I want to show you what we have in animals that have been raised in feedlots. You don't need to look at a graph. Look at the difference here. I mean, and these guys have already been trimmed. They've trimmed probably 4 or 5 inches of subcutaneous fat after they hang them. So most of the fat's been trimmed off, but look at them compared to a wild animal. There's absolutely no comparison. And look at the meat. There's no marbling here on wild animal meat versus what we see over here. So we slaughter cows at 30%, 25 to 30% fat. Look at that. That's 10 times more than what wild animals have. So other issues with the fat comparisons between wild and domesticated animals are the omega-3 fats. And notice then, this is work from our laboratory showing that wild animals, elk, deer, and antelope, have much higher concentrations of these healthful omega-3s. Now, the crucial take-home point here is if you can get it, yes, pasture-fed or grass-fed beef is considerably healthier. If you can get wild meat, better still. Okay, how about salt? Salt is an additive that we all put in our diet. We don't even know it. We eat about 10 grams of salt on a daily basis, and most of it comes from processed foods. If you eat bread, you're getting salt. A slice of bread has about 1.5 grams of salt in it. So you don't think about bread as being a salty food, but indeed it is. So most of it comes from the processed foods that we consume. When did we start including salt in our diet? That's tough to pinpoint because we live near the oceans, the coastal areas, and there's no doubt that people probably dip their food in salt. But inland Europe and other places, the evidence tells us that people really weren't interested in salt. This is an entire mountain of salt in Spain, by the way, and I spoke in Spain 2 years ago, and I threw this slide up there, and people out in the audience, oh yeah, I know where that is, okay. So I just downloaded this, but this is an entire mountain of salt, and the tools that were used to dig the salt out were dated to this time period, so people pretty much weren't interested in it. Okay, how about refined sugars? We eat almost 20% of our calories, depending on whose data you're looking at, 15 to 20% of our calories as refined sugars, and let's see what's wrong with that. Hunter-gatherers, absolutely no doubt, would have consumed honey whenever and wherever they could possibly get it. I've got a colleague, Kim Hill, at the University of New Mexico, now at the University of Arizona. He spent his entire career studying the Ache people in Paraguay, and he tells me that he has seen a male Paraguay shinny up a tree, or Ache shinny up a tree, grab honey out of a wild beehive and throw it down to his colleagues on the ground. And the honey comes with the comb, the larva, everything. And he says he saw a guy eat like 5 pounds of this comb, larva, and honey, and his stomach went like this. So they do it occasionally, but they certainly don't do it on a daily basis because honey certainly is not available day to day. This is per capita disposal data of refined sugars from the Netherlands. And notice that the average citizen, until the Industrial Revolution, didn't eat very much sugar at all. And then from about 1800 until 1940, we got up to over 100 pounds per capita. We see similar figures in England through that same period, and notice the 2 dips during the World Wars when sugar was rationed. This is, so we get up, there's an interesting phenomenon, I'm going to get to it right here in a minute. We get to about 120 pounds per capita, and this is sucrose, or table sugar. So that's about the only sugar we were eating up until the 1970s. This is data in the US for all sugars. We peaked in the year 2000. We went from a 64% increase from 1909 up to 2000. And then we, for the first time in the last decade, we went down just a little bit. So we're doing a little bit better. And this is all sugars, but I'll show you the problem in the next slide. Is starting in about 1970, we were able to take cornstarch and turn it into fructose for the very first time economically through a process called chromatographic enrichment. And we could do this economically, so we didn't have to put a lot of energy into it. It's kind of like a filter. And it allowed us, for the very first time, to make high fructose corn syrup. Fructose is about 50% sweeter than sucrose. So if you're a soda pop manufacturer, that means you don't have to put as much into your soda pop, so you can sell your soda pop cheaper. So it was entirely financial why we change from sucrose to fructose. And this is data from our group and tracking the infusion of high fructose corn syrup into the US diet. Now, when I was in my prime, we didn't get any of this stuff in our diet because it didn't exist. And then by the next decade, by 1980, you can see we slipped a little bit more in. And by 2000, we almost had as much high fructose corn syrup in our diet as we did sucrose. And now we've done a little bit better in the next decade because I think there's political fallout from high fructose corn syrup now, at least not so much with the manufacturers, but with the people and the consumers. So what are the diseases associated with refined sugars? Name a disease that isn't, but particularly, and I haven't listed the epithelial cell cancers, breast, colon, and prostate are all associated with high dietary sugars. Okay, the last item, and we're going to finish up here shortly, and then we'll open it up for question and answer, just a few more slides. Vegetable oils, refined vegetables and oils in the diet. About 20% of calories, and here's where they come from: shortening, margarine, salad oils, and cooking oils. Prior to the Industrial Revolution, and actually the last 100 years, there was really only one way of making vegetable oils. It was with rendering and pressing. So like with olives, they shredded the flesh from the olive, and then they put it into primitive wooden presses, and they pressed the oil out. And that was one of the few vegetable oils that humans consumed until the last 100 years or so. The other way of making vegetable oils out of plant foods is with steel expellers, and that process only happened in the last 100, 120 years, and solvents is even more recent still. So let's take a look here. This is one of these portable steel expellers, and using this machine, we can get oil out of everything. You know, when you think about sweet corn on the cob, you don't think about it as an oily vegetable, do you? Absolutely not. So you can take that and you can squish it with enough pressure, and you can get vegetable oil out of it. We figured out this hydrogenation process in 1897. We could turn vegetable oils into solid margarine and shortening, and that yielded these novel trans fatty acids, which we know now are very detrimental to human health. We ate those for 70 or 80 years before we figured that one out. And this is the data showing how we've increased the vegetable oil consumption since 1909. We've had a 500% increase since this time frame. Now, my grandfather came out to the West Coast. He came out to Hollywood back in the 1920s, and he established a restaurant in Hollywood. And his restaurant served probably between 100 and 200 people at any given time. And so after he died, all of his stuff went to my mom, and after she died, I got all of that. And I remember about 10 years ago thumbing through one of the books that I had inherited, and it was a cookbook from my grandfather's restaurant showing how to make recipes for large groups of people. And as I thumbed through it, and the book was printed in 1913, I believe, as I thumbed through it, there wasn't a single recipe that used vegetable oils. There was a little, I think, olive oil in one or two, but other than that, they simply didn't use vegetable oils. So in the mere frame of 3 or 4 human generations or less, we now have seen this kind of incredible data. Now, what's wrong with it is that vegetable oils are loaded up with a fat called linoleic acid, and they have very low alpha-linolenic acid, meaning that they're high in omega-6s and low in omega-3s. And we know omega-6 fatty acids tend to be pro-inflammatory and are associated with any disease that has an itis on it, such as hypertension, autoimmune, gout, obesity, cardiovascular disease, and whatever. So these are good things to get out of our diet and go back to more traditional oils like vegetable oil. So this is, I had a little bit of fun playing around with the USDA food pyramid and chopping it up. It's now called My Pyramid. And, and so we've eliminated this, and actually if you look carefully down here, I think there's some peanuts, which are legumes. They're not part of the deal either. So eggs and meat and fish and poultry are great, and fruits and veggies. So this is what I recommend for a modern day healthy paleo diet. Is you're 85% of the way there if you do your shopping in the outside aisles of the supermarket. You can get everything you need from fruits, veggies, meats, seafood, healthy oils, nuts, and seeds. As a matter of fact, the diet is much more nutritionally dense when you follow these types of advice. So thank you very much. Okay, so we're going to open it up for question. All right. Okay, over here.
Thank you for a wonderful lecture. Before the lecture, we spoke for a few minutes about inflammation being a key in America. Speak more about inflammation and nutrition, if you will, please.
Yeah, I think that if we look at all the chronic disease in the Western world, what we're really looking at is chronic low-level inflammation. You can't have heart disease, you can't have cancer, and you can't have autoimmune disease. You have to have inflammation to drive the process. So the process can be initiated through other means, but to keep it going, you have to have inflammation. And what we believe is that the gut, the intestinal interface, is one of the major areas where chronic low-level inflammation occurs. So we have an area in our intestines that's roughly 2 football fields in square area. And we're exposed on a daily basis to more antigen, to more viruses and microorganisms in this area than any place. We get a cut, we get a little bit in our mouth, but not even close to the surface area in our gut. And so there are 2 types of bacteria in the gut. There's gram-positive and gram-negative bacteria. And gram-negative bacteria in their cell wall contain a substance called LPS, or lipopolysaccharide. And lipopolysaccharide is a very potent pro-inflammatory compound. And normally that compound in a healthy gut stays in the gut and doesn't leak into our immune system and our circulatory system. I've got a colleague, Patrice Connie, in Belgium, and this is what his group is doing, is that they have developed a procedure to measure LPS in plasma and showing that it is pro-inflammatory. And so a series of papers that have come out in the last 5 years are showing that there's a relationship between LPS and cardiovascular mortality, as well as cancer mortality and type 2 diabetes. So inflammation is part of the Western diet. If you eat wheat, you're probably many people in this room, and most people do eat wheat unless you've got celiac disease, you're going to probably have a slight low-level inflammation, and we can measure it with what are called pro-inflammatory cytokines. And so there are ways of doing it. But yes, inflammation is huge, and elements in the Western diet, cereal grains, legumes, tend to be pro-inflammatory, as do high glycemic load carbohydrates. Mm-hmm. Over here, Dr. Orth.
Thank you for coming here. One of the things I did not notice here, and what I've seen in my 30 years of practice, is that we used to have conferences because we saw fatty liver, and I would give a grand rounds or a talk about it. Today I'll see 4 to 6 people in a day with cirrhosis. And liver disease now in this country, the leading source is probably from obesity for cirrhosis, not alcohol. This entire lecture is all linked to that, and I wonder if you'd go ahead and expand on that.
Yeah, the notion, we talked about high fructose corn syrup, and many nutritionists as well as biochemists realize that fructose is handled completely differently in our liver than other refined sugars. And so what happens with fructose, there's a step in metabolism called the phosphofructokinase step. And what that step does is it regulates the flux of sugars through the liver. And fructose is a very weird sugar, is that it bypasses this. It's kind of a gatekeeper. Think about, it's a water wheel, and it's got this little guy on it that's preventing unlimited flow through that system. And so fructose enters beyond that gatekeeper step, and fructose then in the liver serves as a substrate to build fat. And so the liver actually builds fat. There's something called acetyl coenzyme A and another factor. You don't need to know the biochemistry. And that promotes the synthesis of fat in the liver. And so it's not surprising, because that pathway exists, that we find this. Now, on an evolutionary scale, why should we have that pathway? It makes a lot of sense. If you're a chimpanzee and you're living out here in East Africa and fruit is only available seasonally, what you want to do is you want to turn it into fat immediately. You want to store, so when the fruit is ripe, you want to be able to metabolically store those calories. You don't want it just to come through your body. So on an evolutionary perspective, it makes sense to have that. But when we have unlimited high fructose corn syrup, no exercise on top of a high glycemic load, it's just pouring gasoline onto the fire. Back there.
I didn't see anything mentioned about the effects of all these diets on your teeth and how that might influence cavities and plaque formation and stuff like that.
Yeah, you know, that's a very good question, is that teeth are remarkably preserved in the fossil record. And what we find is we can go backwards in time and look at dental caries. And prior to the agricultural revolution, in the course of a lifetime, if you pull somebody's teeth out of their mouth, the incidence of caries are like you got 32 teeth, you know, maybe one tooth, two max, might have caries in it. And it's usually because of not the type of way caries are formed today, but because there's been physical damage to the enamel. But there is very, very low incidence of caries in living hunter-gatherers. They don't have toothbrushes and they didn't have dentists, okay? They didn't floss either. They did do a little bit of flossing. They got things out of their teeth. But there was no hygiene like what we do now. So the big caries source happened, and you can go back in the historical literature, is right at the Industrial Revolution, is that there was no such thing really as dentists. That wasn't a profession, and toothbrushes, you know, were not, you know, pervasive in the society. So we don't see it until literally the Industrial Revolution with the advent of sucrose. And what sucrose does is it encourages the growth of a specific type of bacteria on our teeth, and the acid from their metabolism erodes the enamel, and that's what causes caries for the most part. Yes, right over here, and then we'll get up to this.
Yes. Is honey any better than sugar? And also, is olive oil any better than any other oil?
Is honey any better than sugar? No, honey is a mixture of glucose and fructose. High fructose corn syrup, guess what? It's a mixture of glucose and fructose. So honey metabolically does the same thing to our bodies as high fructose corn syrup. It's not, sucrose on the other hand is a compound, all right? It's a disaccharide. And we have enzymes in our gut that have to break that compound down, so it's released more slowly. So honey is not a good thing. And what was the question about olive oil?
Is olive oil any better than any other oil?
Yeah, I think olive oil is a very healthy oil. It's a monounsaturated, meaning that it's stable during cooking, so it doesn't break down. It tastes great, and it's got the approval of 5,000 or 6,000 years worth of testing on it. So I think olive oil is a great oil. The only downside to olive oil is that it is fairly low in omega-3s and fairly high in omega-6s. But if you include fatty fish in your diet or you supplement, it's not a problem. So olive oil, I would encourage you to. And extra virgin olive oil is actually better because it contains more polyphenolic compounds that are anti-cancer. And so, yes, over here.
I'm confused. I am the daughter of someone who took her degree many, many years ago in nutrition. I always thought that if you were careful and ate cheese, cottage cheese, milk, and those things, it would help prevent osteoporosis. And I think what I heard today was it's just the opposite. So I'm confused.
Well, I would say that cheeses are probably not a good thing to do to prevent osteoporosis. And you saw my slide up here when we looked at the acid-base balance. They have almost an order of magnitude greater acid load than milk. Now, milk is neutral. But let's once again look at the evolutionary evidence. We've been on this planet for 2.5 million years. We've been only drinking milk for less than 10,000, less than 300 human generations. how in the world do all the other animals on the planet, including all the other primates, build bones without milk? There's no single animal on the planet that drinks the milk of another species. So the answer to that comes into, it's like a bank account, all right? When we look at bone metabolism, we focus upon what the dairy industry, the milk mustache people want us to focus upon, is that it's all about calcium coming into your body. But what you do is when you send your kid off to college to get their degree in nutrition and you give them their checking account for the first time, do you say it's all about how much money comes in? No, it's all about balance, isn't it? So it's the difference between the calcium coming in and the calcium going out. Any good accountant, you have to look at the difference between what comes in and what goes out. And so that's the important issue, is calcium balance. And when we talk about acid-base balance, is the primary mechanism by which we lose calcium is this acid-base balance. So if you don't eat fruits and vegetables, which we don't, we only get less than 10% of our calories from fruits and vegetables. We're all have a slight metabolic acidosis. So the solution, it had to have been, that evolution worked out, was that yes, we can build strong bones. How do you think elephants in the jungle build these gigantic bones? They don't drink milk. Is that we have these physiologic mechanisms in play, and the bones are like any other organism, is that they operate well under the environment in which they were selected. And so we've completely disrupted that environment. We eat 10 grams of salt a day. Salt has been shown to promote osteoporosis. If all you do is take salt out of the diet of women and you put them on a DEXA scan, what we've found is after a 2-year trial, their bone mineral density improves just by getting salt out of their diet.
So if you are a cheese addict, do you eat a lot of you drink wine and eat a lot of fruit with it and it balances it out?
There you go. Perfect. All right. I can go for that. Okay, how about way in the back here, because I haven't gotten back there. Yes, I do. You know, I think that people eat for many, many reasons, you know, and I think that we need sustainable issues as well. But I had lunch with some very interesting people today, and we were talking about that very same idea. And there is evidence to suggest that a soybean field that is 5,000 acres does more damage to the environment. What we're doing is we're trading oil for soy. And would you rather trade grass for high-level protein? And so we've invented this wonderful machine we call a cow, and the cow takes grass that we can't eat and turns it into something we can. So when we make a field of soybeans, we're taking oil from the Middle East and fertilizing it to make a food that is potentially damaging. So I think that, you know, some of these issues clearly aren't clear-cut. I respect anybody who has religious beliefs or ethical beliefs for not eating animals. That's fine. But I can guarantee you, you're misguided if you're eating a vegetarian diet for health reasons. And so we have 2 more questions here. Okay, ma'am, right here. You know, I'm writing my 5th book right now, and writing a book is as painful probably as it is for women to give birth. I hate it, but I'm happy to get what I see, you know. And I've got a chapter in there on artificial sweeteners. And the FDA, the Food and Drug Administration, has sanctioned 5 different sugars. And to my way of thinking, they're controversial. It's not as if all the animal studies show that they're safe. The animal studies can go either way. The epidemiologic studies, the population-wise studies, generally show them to be safe. But to my way of thinking is, once again, the evolutionary template tells us that if you want something sweet, you get a piece of fruit or something, or vegetables or whatever, But I don't know. I don't claim to know everything about nutrition and the xylitol issue. I've heard a little bit. There's pros and cons to it. But my feeling is that particularly aspartame, that's a nasty substance. And aspartame you ought to get out of your diet, because I think that there's significant information. A paper just came out this year in the American Journal of Clinical Nutrition, and it showed that the risk of preterm birth in women who are taking a lot of aspartame goes about 3-fold higher. So that kind of information is not tested early on, and we find out after the fact that we shouldn't be doing these things. So it's kind of like introducing high fructose corn syrup. What a bad idea. Well, we can't, it's very difficult to go backwards in time. It's like cigarette smoking, you're never going to get rid of it. You need to educate people. So I think that's the issue, is education rather than legislation.
Last question.
Okay, this guy over here, he's had his hand up the whole time.
Thank you. They're very good presentation. And
Thank you very much.
for the last 10 or 15 years, I've been trying to do what I call the caveman diet without this much information, so I like it a lot. And I'm convinced that beer is on the caveman diet. But my question is, why don't Eskimos get scurvy?
That's a good question, and it's because the word Eskimo actually means raw fish eater, okay? So in the Inuit language, that's what it means. And if you think about it, when you eat a vegetable, you have vitamin C in all of your tissues right now. And so when you eat meat raw, it has just enough vitamin C or fish in it to prevent scurvy. So they're getting probably less than 30 milligrams a day, but that's enough to prevent scurvy. So that's how it works. And you know what? One other thing along the same lines, and I know Ken wants to call this thing, but have you ever thought about anybody here that is into exercise or fitness, you realize that when you go into a running race, many people carbohydrate load, don't they? During, yes. So we're getting all this glucose into our muscles and glycogen. Glycogen is a form of glucose that we store in our muscles. And so we have sugar in our muscles. Well, when you go down to the supermarket and you buy a piece of meat, what happens to the glucose or the glycogen that was in your muscles, in the cow? Because the cow has the same thing. Anybody have any idea? So well, the physicians here in the crew ought to know. What happens to somebody when they die? What happens to their muscles? Rigor mortis sets in, doesn't it? And what drives rigor mortis, what allows the muscles to contract after death, is the residual glycogen. And then when the glycogen is spent, the muscles relax. And so that's why if you eat a cow or an animal immediately after you slaughter it, you have a little bit of glycogen in it. But once rigor mortis is done, there's no carbohydrate or glycogen in meat. So thank you very much. I've enjoyed it. Pensacola.